Hey everyone, this is the Chapter 2 review quiz, and we're just going to go ahead and go over it. And it starts with this question: the function f of x is equal to 5x plus 7 over x minus 1, and we note that x cannot be 1. And we're going to look for f inverse of x. So I've got this written out where we can work, and I'm going to go ahead and start looking for f inverse. Now we know that a function composed with its inverse is going to give us x. So I've replaced x with f inverse. That's here and here. And I've set it equal to x. So now we're going to solve for f inverse. I'm going to start by multiplying. So we'll have 5 f inverse plus 7 is equal to x times f inverse minus 1. Alright, so let's distribute here. We're going to have 5 f inverse plus 7 is equal to x f inverse minus x. Let's get this over here. So we'll have 5 f inverse minus x f inverse, and then that's going to be plus 7 is equal to negative x. Okay, and this is where it's going to get a little tricky. I want to take this f inverse, I want to factor it out. What'll be left is 5 minus x, and then that's plus 7 is equal to negative x. Plus 7 goes to the other side, so we have f inverse times, let's make that a times, 5 minus x is equal to negative x minus 7. And now we're going to take this and divide. So we'll have f inverse is equal to negative x minus 7 over 5 minus x, which I'm going to write as negative x plus 7 over negative x minus 5. F inverse of x is equal to x plus 7 over x minus 5. All right. So we had number 2, find the slope of the line passing through the pair of points. And we have negative 3, negative 7, and negative 1, negative 3. So that's going to be negative 3 minus 1 over, oops, not minus 1, minus 7. Negative 3 minus 7 over negative 1 minus a negative 3. My apologies. So that's going to be negative 10 over 2, which is negative 5. So the slope is negative 5. And does the line rise, fall, horizontal, vertical, what? Well, this negative slope is decreasing, so it starts up here really high, and it's going to go downward. F of x goes down as x goes up. So the line falls from left to right. Okay. Use the transformation of the graph f of x cubed, I should say it correctly, to determine the graph of the given function, x minus 5 cubed minus 6. So, 2 parts here. Let's take a look at this x minus 5 business. That's going to be right 5, so we're going to go that way 5. So that's right here. And then the minus 6 on the end here, minus 6 on the end is going to be up 6. Not up, down, because that's the one that goes in the same direction. So down 6. So I'm going to go down to 5, down to 6 right here, right? And that's the center of our graph. And we need to draw this like it's a cubic, so that means it needs to go up 1, 1, down, and then kind of out cubic style from there. And we could grab some actual points and plots, but it's something that looks like that with the flat bit at 5, negative 6. Because remember, a cubic kind of looks like this. And this is the point minus 1, the point 0, 0, and the point 1, 1. And then over here it's at 2, 8. So this point 1, 2 away should be up 8. So at 2. Over 2, so it goes from 5, so it should be at 7, 2. Should be on this graph here. 7, 1, 2. Hey, look at that. 7, 2. Cool. Find the domain of this function. We're going to take x squared plus 18x plus 65 and set that equal to 0. So I've got this written out now where we can work. And let's mark that at 7 minutes, and this is on 121 review. This is 065 part 1. Was that 4 minutes? Okay. 3, 2, 1. So I've got this written out where we can work, and we've got some blank space, and we've got to factor it. Maybe we can take a look at the factors of 65. 65, does 1 go into it? So 1 plus 65 is 66. No. 2 does not. 3 does not. 4 does not. 5 does. 5 times 13. So 5 plus 13 is 18. Look at that. That's a match. So these are going to be our numbers for our factorization. X plus 5 times x plus 13, that's equal to 0. Great. So x is going to be equal to negative 5, negative 13. Now in the context of our problem, this means that x cannot be negative 5, negative 13. So what's our domain? Our domain is going to be equal to, well, negative's fine, right up to negative 13. We can be between negative 13 and negative 5. And we can go on from negative 5 straight on to infinity. But we just can't have these 2 points, negative 5, negative 13. Those just can't be in our domain. So we've got the holes in there to take them into account. All right, let's keep moving. Use the graph to determine the domain, the range, the x-intercepts, and the y-intercepts, and the missing value right here, which is 9. So we've got this weird kind of square root-ish looking function it could be, and we're looking for the domain. Now there's nothing over here in the negative space. There's nothing over there. I'm going to grab a pen and say, look, there's nothing. So for our domain, it starts at 0, and then it's going to go on straight to infinity. That's our domain. What about the range? Well, this right here at negative 1, negative 2, that's our max. So for our range, we've got a maximum at negative 2, but it looks like we can be as low as we'd like, so negative infinity. There's no minimum there for the y height. This will just keep dropping down for all infinity. So that's our domain, that's our range. Let's clear this out here. Oops. Erased so hard I moved the page. Determine the x-intercepts, if any. So where's this going to intersect the x-axis? Well, it's at negative 2, right? That's its maximum, and then it goes down. So the highest it hits is right here at negative 2. So there is no x-intercept. What about the y-intercept? That's right here at 0, negative 2. So the y-intercept is negative 2. And what's f of 9? Here is 9. 9 looks to be about negative 5. F of 9 is equal to negative 5. Great. Now let's use the transformations of f of x is equal to x squared. And remember, x squared looks a little something like this to graph this function. X squared, or x minus 1 quantity squared, then plus 2. So x minus 1 means we're going to go to the right 1. So to the right 1, there's that. And then plus 2 means we're going to go up 2. So 1, 2, there's up 2, and there's that new vertex there. 1, 2. Great. And then we go up 1, over 1 right here. That points on it. 2, 3 is there. And then we're going to go and mirror that over here. So we'll be at 0, 2. Great. And then maybe if we want, we can put another point in here, like 4 minus 1 squared plus 2. That's 3 squared plus 2. That's 9 plus 2. That's 11. So at 4, it's at 11. That's up here somewhere. So we've got something at which to aim. And we can just, and then come over here and just, and that's our graph. Evaluate the piecewise function at the given values of the independent variable. So g of x is equal to x plus 3 if x is greater than or equal to negative 3. Negative x plus 3 if x is less than negative 3. And we're going to look at g of 0, g of negative 7, and g of 2. So let's start with g of 0. 0 is greater than or equal to negative 3. So g of 0 is equal to 0 plus 3, which is 3. Great. Now let's do g of negative 7. G of negative 7. Well, that falls into this bracket. It's less than negative 3. So that's negative 7 plus 3, which is negative 4, which is 4. So g of negative 7 is 4. Okay, last one. And I guess I'm going to try and draw a triangle around g of 2. G of 2 is, let's see here, 2 falls into this region again. 2 plus 3, which is 5. So g of 2 is 5. Okay. Next question. Look at this. It's another graph transformation. For the absolute value function, negative absolute value of x plus 2 plus 4. What transformations are needed in order to obtain the graph of g of x from the graph of f of x? Select all that apply. Well, this x plus 2 right there, that tells me that there's a horizontal translation. Then, look, we've got this plus 4 on the end. That's a vertical translation. And last, our last piece right here is this negative sign. And what that negative sign tells me is that we're going to have some sort of reflection. Now, is that about the y-axis or the x-axis? That reflection is going to be about the x-axis. Okay, so for example, if I take g of 0, that's going to be negative absolute value of 0 plus 2 plus 4, which is negative 2 plus 4, which is 2. Okay. What about g of negative 2? That's a good example there. That's negative 2 plus 4 plus 4. This all drops off, so that's going to be, oops, should be 2. So that's going to be 4. G of negative 2 is 4. So this point was at 0, 0, right? The point of an absolute value is normally at 0, 0. And this is the absolute value of x. But we're moving it 2, so if I have the absolute value of x plus 2, that's going to go to the left. So that's going to be at negative 2, 0. That's where that point's going to be. And then that plus 4 is going to move it up. So that's going to be, how do you indicate up? Negative 2, 4. And then it's going to get flipped around because of the negative sign. So that's going to make it go like that, right? And we already have an idea of some of the points. At 0, it's 2. So I can start looking in and find one with 0, 2. And this absolutely is not it. No. This not flipped. And this not flipped. So it's got to be A. A has got to be the one because it's flipped. It hits at 2. That points at negative 2, about 4. That looks like it right there. The graph and equation of the function f are given. Use the graph to find any values at which f has a relative maximum, and use the equation to calculate the relative maximum for each value. Use the graph to find any relative minimums, and again calculate the minimums. Okay, so what we're looking for is the maximum and the minimum, and the maximum is up over here, the minimum is down here, and this is kind of hard to see, but it's at negative 5 to 5, so that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, so that's negative 5. And then this here is at negative 3. So for our max, this is going to be f of negative 3, which is 2 times negative 3 cubed plus 6 times negative 3 squared minus 18 times negative 3 plus 5. Oh my goodness. You know what? I think we're going to grab our own calculator to solve this. So I pulled up my calculator. I'm going to take negative 3. I'm going to store it as x. And I always like to do that when I'm doing these sorts of calculator inputs, because chances are I'm going to be inputting this function a couple of times. We square it, we subtract 18x, and then we add 5 to it, and I'm going to get 59. So a function has a relative max at negative 3, and the relative max is 59. Does that match the scale? Yeah. So this is 80 up here, 80, 70, 60, up right around 60. Yep, seems right. And then we're going to do the same thing again with the minimum. And I think the minimum is occurring right here at x equals 1. So we'll go back to the calculator. And what I'll do is I'll take 1. I'll store that as my new x value. I'm going to go back to my old input. And we get negative 5, which again seems to fit and seems reasonable. That could certainly be negative 5. So it has a minimum at 1, and the minimum value is negative 5. All right, great. Let's take a look at this next function. We're asked to figure out if these functions are inverses of each other. Only one way to do that. I'm going to take f of g of x and see what we get. So that's 5 times x plus 5, x plus, we'll write all of g here in green, g for green, x plus 5 over 8, and then we're going to subtract 8, and I guess f is in red because it's fiery. This isn't going to be x. This is going to be 5/8 x plus 25/8 minus 64/8, which is not x. So, are they inverses of each other? They are not. And we'll also find g of f of x. It seems to want us to find that too. So we'll say g of f of x is equal to 5x minus 8 plus 5 over 8, which is 5/8 x minus 3/8. So 5/8 x minus 3/8, and this is 5/8 x, and that's, I get 19/8, right? No, 39. My goodness, I can't subtract. 64 minus 25, 29. Minus 29/8. Okay. I might not be able to subtract, but I can graph, and I can take a slope and an intercept and graph an equation. I'm going to start with the +8. I'm going to find +8. Bloop, right there. I know it's passing through that point. 0, 8. -2 tells me to go down 2 to 6. And then that 9 on the bottom tells me to go to the right 9. Here's 10, so here's 9. That looks about right. And let's connect these with a line. Yeah, that's a really bad line, but I think we can adjust it. Oops. I think I can adjust this line. Well, pass that through there. Pass that through there, about like that. Sure, great. That looks pretty close. But the key right here is doing that down to the right 9 idea, and knowing that you start at 0, 8. So the slope of the line is -2/9. The y-intercept is 8. And there's our graph at 0, 8, and then down 2, and to the right 9. I'm going to pause the video right here, and we'll pick this back up in our next video. This is getting a little long. Alright, see you next time.